Problem number 6. So we want to find the value of c that makes g of x continuous at every single point. And this is our g of x, this piecewise defined function here. So what do we need for continuity? Continuity. We need 3 things. F of a exists if we're continuous at a. F of a exists limit as x goes to a of f of x exists. And these 2 things are equal. Remember, that's what it means for a function to be continuous. Okay, so 1 we have check marked for free because I can just plug in. So I need to make sure that this limit exists. And when I do that, I'm going to make sure the other 2 things hold. So first, this function is defined at every point in its domain. And if c is not 2, then it's going to be continuous because we know that this top function is continuous everywhere on its domain because it's a polynomial. And the same thing for the bottom. So the only real question we can have is what happens at 2? Do these 2 functions meet up at the right place or do they not? And we're going to fix it so no matter what they do. So what happens? We set the left limit equal to the right limit. So we set limit as x goes to a from the minus of f of x equal limit as x goes to a from the plus of f of x. Once those 2 limits are equal, then we'll be done. Because the limits will be equal and f of a just says plug in anyway, so nothing's going to change there. And we'll be good. So the limit as x goes to a from the minus of f of x. Let's go ahead and take a look at our function. So if we're less than 2, we are x squared plus 3x plus c. And as a matter of fact, I don't want to say a here because I know the number that I'm interested in. As x goes to 2. So we have 2 squared plus 3 times 2 plus c equals 2 squared is 4, 3 times 2 is 6. So this is 10 plus c. If we come at it from the other direction, we have used the top function, 3 times 2 plus 2, which is equal to 8. And now I said I was setting these 2 limits equal. So 10 plus c equals 8. Or subtracting 10 from both sides, I get c is equal to minus 2. And this guarantees that these functions graphically kind of meet up, that we don't have a jump discontinuity there. The c will make sure, yep, they actually come together the way they're supposed to. So because of what we did, the function will look something like that. Where here's 2, here's where they're kind of conjoined. Whereas if c were maybe a little bigger, our function would look like that on the bottom. And because c was too big or too small, they wouldn't match up quite right. So that's what we're doing, is we're just kind of moving the function, translating it up or down, so it locks in really nicely. But that's it for problem number 6.